Sun was quiet. The coronal holes turning through are small. The solar flaring is completely absent at the moment, and so we look to the solar wind. We find a plateaued stream slightly above average ambient intensity, but holding steady, and Earth's magnetic field is calmly handling the plasma pressure. Wanted to do a multi-wavelength zoom in on those filaments, those solar tornadoes of plasma. You can see how they look in ionized iron here and in ionized helium. The filaments are vertically oriented at the lead and are spilling up and out to lower latitudes. These filaments don't stay stable for long. Expect either a collapse or an eruption soon. Quick shot from GO 16 up next. While Fred made landfall, I eagerly awaited something in the eye wall, and it lit up nicely. The little arc flashes are indeed in the core of the storm, wrapping around the curvature of the clouds. Folks, that big quake in Haiti caused a lot of landslides, and one photo says it all. The brown areas are the landslides from a nearly pristine mountain range beforehand. Folks, this next one reminds me of that Romanian scientist in 2012 who said the Sunda arc was destabilizing. It appears he was right, and it has continued. The Sunda arc is one of the most dangerous faults in volcanic areas on the planet, and it has been increasingly active. And this is where we've seen disturbances under the ocean, and it's where the north and south magnetic poles are set to meet here in their ongoing excursion. Not terribly surprised, the area is destabilizing. Folks, if you didn't catch last night's video, it should really help solidify your idea of the water, storm, and lightning connections with the Earth's magnetic shift. Seems most observers are liking it a lot if you haven't caught it yet. Now, last but not least, let's learn about the sun's interaction with the galactic current sheet. Voyager coming in here showing the flux tube magnetic connections between the interior and exterior electromagnetic systems. It's formed at the boundary interchange instability. The flux tubes they are describing are similar to the well-known flux magnetic connection between the Earth and Sun, and in the interchange instability, those flux tubes tend to be fluted, a helical flux tube. You are also familiar with these instabilities as the auroral beads on the string at the top of the sky, and space weather watchers are firmly familiar with the shape and interaction of Earth's magnetic field with the surrounding solar wind plasma. We know those flux tubes interchange material at Earth during these times and strongly affect the vertical winds. These are another part of the vertical flux of the upper atmosphere, and they've known about these for a long time. It's that vertical flux that they're talking about at the sun and galactic scale. Back here on Earth, they have known for a long time that these are dynamically forced by the solar wind and geomagnetic conditions. They know that Joule heating is the key to that vertical wind forcing, and that it works in the thermosphere, mesosphere, and even down to the upper atmosphere. The vertical flows are both ionic and neutral, with the larger scale polar flux being the biggest and the geopotential height tracking telling us about the smaller ones. Every pressure cell is bobbing, either up or down in a slow vertical flow, again tamed by the global electric circuit, modulated by the solar wind. Even at ground level, as we look at wind map shots of a high pressure cell top left and a low pressure cell bottom right. Lows always draw the wind in, high pressure always pushes out, but in the low, sucks into where? An imaginary black hole? In highs, spreads out from where? Air's just manifesting in the middle of the cell? Of course not. The interchange is upward, vertical. The air goes down to the ground in highs and back up to the sky in lows. And so we take this large-scale vertical flow forcing and apply it to the sun at the galactic scale. The sun doesn't take CMEs and flares. It takes interstellar magnetic field shifts in the galactic current sheet. Those are the sun's version of experiencing space weather, and during those events, the interchange instabilities grow and enhance, and what Voyager likely saw was the fluting instabilities, or interchange instabilities, of the galactic current sheet interaction with the heliosphere, and the ions go up or down. If these systems weren't scalable, if they didn't work the same way, Voyager wouldn't have seen those plasma instabilities.